Let me just check this one. Okay. In the last class, in the previous meeting, we stopped here at instrumentation process control chapter 2, which is a sensor, right? Sensor, as I explained to you, this one is can be categorized as one of the important element for instrumentation and process control, in which without the sensor, definitely we cannot achieve any process control or instrumentation. Okay, so these are the one that first detect what to do during the overall process. I think in the last class we stopped at this point. Where is it? Okay. Right. I think we stop at this point, and I advise you try to understand this work example, and I hope everyone uh, did some revision on this one. Just 5-10 minutes revisions, and probably I will I'll pick randomly any of you for this to explain this work example. Okay. I need to pick here lah, as usual. Okay. May I know who is Haji Charlie? This one. Haji Charlie? Haji Charlie ke Kali? Who is this guy? Haji Charlie? Please respond. Anyone? Anyone? Haji Charlie? Haji Charlie? Apa ni? Hey. Haji Charlie, please. Siapa? I want to know you. Is it Abdi Wali, the international student?
I don't know, Doktor.
Sorry, I can't hear your voice.
Tak tahu, Doktor. Tak kenal.
Tak kenal eh? Who is Haji
tak
Charlie?
kenal.
Haji Charlie, can you please unmute? I want to know who are you? Okay, it's okay. Nanti saya trace belakang lah. Okay, by the way, I would advise every one of you to sign in or to join the Google Meet using the official UTHM email, right? For Haji Charlie, this one, I don't know who is he, and I just simply admit. I don't know whether I can remove. I can remove. Haji Charlie, can I just remove you from the class? And join using the official UTHM email?
Hello?
Yes.
Yes, Doctor.
What's going on? What's the problem?
The problem, and I have using for my friend laptop, so I bought wrong email maybe.
Can you log in using your UTHM official email?
Okay, I will try.
Okay. Okay, alright. Saya panggil ni lah insan terpilih ni. Haris lah. Muhammad Haris Akmal.
Ya, Doktor.
Okay, Haris, saya nak tanya awak. Awak dah go through this one?
Belum, Doktor.
Kenapa belum? Kenapa belum, Haris?
Kenapa, Doktor?
Okay, Haris belum. Saya tengok Nabil Fikri. Nabil Fikri?
Yes, Doktor.
Awak dah go through this one?
Belum juga doktor.
Kenapa belum? Kan saya pesan kan, macam I remind you all to go through this one quickly, and then I'll pick you randomly to help me to solve the problems. Okay. I don't want to waste time just to ask every single of you. It's okay for now. And then whenever I assign or ask you to do something for the next class, I would appreciate if you could do that. Okay, a little homework, the one that at least the one that I advise you during the class. Okay, I don't expect more, but at least the one that I requested in the class. Especially those the one that I promised to ask you randomly in the class. So just be prepared. So I don't want the same problem happen for upcoming class. Okay, Nabil dan siapa tadi? Nabil dan Haris.
Ya,
Boleh?
sir. Boleh, sir.
And this reminder goes to
Yes,
everyone.
doktor.
I do believe if I ask every single of you, maybe there are more will declare that you haven't done anything on this one. Okay, but that is fine. This is take it as a first and last reminder from me so that we can tu belum lagi saya tanya tu my lecture on the apa VAF. Itu belum saya tanya tu. My lecture, recorded lecture, the one that I provide to you, and that we go for asynchronous class, itu belum lagi saya check. Kalau saya check, saya buka certain pages and I ask you for detail, saya worried you will answer the same. Okay, please be remind again, things that I remind you in the class or anything that I remind you to do, please do some little homework, at least go through once. At least go through once, and at least if I ask you to explain to me, you can actually ask me or argue with me or sorry, I don't understand what is this. It's okay, apologize for now, but not to repeat in the future. And please again, please review those who haven't reviewed or haven't listened to the chapter 3, which is about the valve, the complete lecture on that chapter. And then I would advise you, after this class, you may use your own time to review before the next class, so that if I ask you any questions, you don't come up with the you haven't reviewed that one. Okay, this is kind of gentle reminder to everyone, and hope this one is the first and the last. All right. Okay. Okay, if we look at this sensor, okay, last week we discussed a couple of things. Okay, we want to know the criteria of the sensor, and then some formulations related to the sensor. I mean the process or the overall process, how we actually implement or incorporated the sensor, and we come to the first sensor, which is the flow sensor. All right, the flow sensor, and in this case we are using the orifice meter. Okay, orifice meter. We are using orifice meter or system to actually measure the fluid flow. How they measure the fluid flow is actually by using the concept of the pressure difference. Once we introduce the orifice plate, okay, once we introduce the orifice plate within the pipeline, and we have a small hole, a certain hole, and then a flow from one side to the other side, there will be kalau kita tengok kat sini, if we look at this point, there will be a pressure different at this point. Satu pointer. Sorry. Okay, if we look carefully at this point, okay, there will be a pressure difference between these two sides. Okay, we declare this one side A and this side B. A and B will be a pressure difference, and then we put a small tube here to really detect the difference, and then the difference in terms of the pressure will be in terms of this one delta. This one we call it delta P, which is pressure, by using orifice. So we know the pressure difference, then we can actually correlate to the flow. Okay, the flow sensor. Right. So this is a simple. We don't need to worry about the derivation. We just use the formula. In this case, what most important that you need to know is actually F. F flow is equal to K is constant to the times square root of pressure difference. Pressure difference 1 minus pressure difference 2 between two regions. So it'll be a delta P here. So square root F flow sensor by using orifice plate is equal to K constant again and the pressure difference. In this case, when we are using the orifice meter, we need to assume it is a constant density. We need to assume constant density. Density, so fluid between point section A and B, they are remain the same, right? And in this case, since we assuming that the fluid density is identical, so we don't need to worry about the measurement of the liquid density. Okay. So, okay, now we come to this simple example. A flow of a water drinking process is to be controlled from, kita tengok all the parameter given, 0.8, okay, 0.8 to 3 gallon per second. This is, we assume is a crude oil maybe, 0.8 to 3 gallon per second, okay. Below, what is below? Below is some sort of a device that used to detect the pressure, to detect a movement. Nanti ada tunjuk contoh billows. We call it billows. The billows measure, okay, maksudnya dia billows ni adalah macam ni lah, macam if you are using you want to pump in your bike, or you somehow we use a diaphragm in which a plastic one that you can use press and compress, so that we pump in the the wind into the ball or anything, the flat tire. That is what we call billows. Or simply you can actually Google lah. It's very simple. Okay. Then billows measure pressure using orifice plate with a constant pipe, with a constant for the pipe and liquid. Okay. Of a constant of the pipe is actually 119.5 gallon per minute per psi. Okay, these are the constant value. Okay, what is K? Take a note about the unit here, gallon per minute per psi. Okay, what it means, if the constant values is given in for example gallon per second, what you have to do, you have to convert it into a minute. All right. If the pressure is different in term of bar, for example, PSI is a SI unit for pressure. Maybe just to test you, the value given is actually in bar. So what you have to do, you have to convert it the PSI, the bar into the PSI unit first. Means that you need to obtain the gallon per minute per PSI, right? And the linear variable differential transformer, okay, LVDT. Okay, this is a special term ataupun special device that been used to correlate the output sensitivity in term of voltage. Sebab macam as I told you before, part of instrumentation and process control is actually, okay, we have several component. We have we have the overall process, and then the component of it, one, we need the sensor. Then we need a communication between the sensor and the actuator. The actuator is the one that will operate the final control element. The final control element, which in this case, instrumentation and process control, normally it refers to the valve. Okay, whether we want to slow down, we want to open up the valve or device. So we normally communicate. Obviously, the data between one point to another point need to be translated into some sort of the one that can be the one that can be read or measured by using signal data or maybe voltage and current. That's why the pressure in terms of flow, they are all been converted into voltage per psi, so that we can correlate or we can easily transfer the data in terms of the output. Okay, now determine the range of output voltage of the LVDT. Okay, determine the range of output voltage. What is the range of output voltage? Is very simple. Say for example, we have a gauge, okay, a thermometer, very simple. The range of the thermometer for water, normally we will have only 0 to 100 degree Celsius. This is the most common value that been used to detect the boil the water. Means that 0 to 100 degrees Celsius. Okay, what is the range of this one? We want to know exactly what is the range for this LVDT for each particular applications. Maybe from 0 to 5, maybe from 0 to 50, and maybe from 0 to 100. Of course, when we are using the very wide range, we need to compromise with the sensitivity. If we go for a very narrow range, or maybe a very small range, means 0 to 5, for example, you might we will have end up with a very sensitive the sensitivity will be increased, and maybe we can actually measure in terms of 2 decimal places and even more. Okay, so that is the with regard to this one. Okay, bear in mind this one need to translate it first, and we are using the gallon per second. If you can see here, the the parameter given here is actually 0 gallon per second, while the constant is given gallon per minute. So what you have to do next is actually first we need to obtain the flow. Okay, the flow Q. Q is actually the flow. Okay, Q1. Okay, Q1 is equal to 0.8 gallon times 60. Why is 60? Because the value given here is per minute. So we want to have the values in terms of minutes. So we need to multiply by 60. And then that will give us equal to 48 gallon per minute. This is the first step. Why? Because the parameter or the constant given here is actually in gallon per minute and per psi. So next step, how to know the pressure difference between the orifice plate. Okay, orifice plate ni is actually a sensor, as I explained before. So we need to measure the pressure difference. What we have to do, actually, we need to refer to this formula, the one that I've told you before. Okay, we know that the flow or Q is equal to K times square root of delta P, or pressure difference, or P1 minus P2, or the difference between two section. Okay, so when we come to this one, so in order for us to obtain the delta pressure, so it will be Q Q, which is F in this case. So rearrange this formula will give you delta P, which is pressure difference. All right. So it's just a very simple mathematic. So you can calculate, and that will give you 0.16 PSI. Okay, PSI. Why PSI? Why not bar? Because pressure can be and another unit for pressure is bar. Okay, why PSI? Why do you know this one is PSY? Is because the given parameter here is in PSI. All right. So if the values given here in bar, so definitely this one will be 0.16 bar. Okay, as simple as that. That's why you need to make sure the unit is consistent with this constant. If they use gallon per minute per PSI, you need to convert all the given parameter in term of minutes, in term of PSI, and vice versa. Okay, now we obtain two values, and finally, we want to know the sensitivity and the range. Okay, we know that output sensitivity is 1.8 volt per PSI. So we know this one is 0.16 PSI. So what we have to do is we can actually multiply 1.2 times the pressure difference. Okay, so that's why it gives you 1.8 times 0.16, and that will give you 0.29 volt. Okay, so what happened in this case when within the pipeline? Okay, so the one that you see in the the one that you see in this device will actually show you the with the pressure difference. The voltage will be 0. Okay, 0.29 volt. This is the one that you see. Okay, now we know that the flow section for the second section is 3 gallon per liter, per second. Okay, now we calculate the value for 3 gallon per second, and then that will give us the same. We perform the similar calculations, and then that will give us V1, or this one V2. We say V2 1.8 because it says 1.8 the sensitivity, and we know the pressure difference between in the section 2 is actually 2.27. 2.27. So we multiply the value of the sensitivity, and then that will give us actually 4 volt. Okay, so from here we can actually know that the VLDT, variable different transformer, ataupun linear variable differential transformer, the reading will be between 0.29 to 4.1. These are the sensitivity that based on 0.8 to 3 gallon per second. Okay, so that is the range of VLDT. A very simple formulation. What you have to know, and you have to be very careful here is actually this formula. Rearrange this formula, and then be careful of the unit, gallon per minute per PSI. Okay, then you can actually calculate what is the range of VLDT. And from this example, we can actually, by using the same formula, you can actually calculate what is the minimum gallon per second on the section A and B. You can calculate many things just based on this formula. The questions or the and some numerical calculation may involve you to calculate the flow, the voltage, the minimum voltage, what is the pressure difference. But you have to know and to fully understand every single word that been used in this section. Like this one. And they are here for something. So we have to be very clear with this one. Okay, now flow measurement. Okay, we have a pipeline. We have a restriction. As I explained, the concept of the flow measurement is by using the restriction. Just like orifice plate, we put some plate in between with a small hole that will introduce a pressure difference. And like this one, the restriction flow sensor also will involve something related to the restriction of the flow of the liquid. Okay, means that the first method to measure the flow sensor or the flow of a liquid is actually first by using orifice plate. Okay, how? As I explained before, and these are some other option, some other option that been introduced to measure the flow, to measure the flow. So one option is, if you can see here, there is a notch here. Notch means that the pipeline, and there is a point that between the diameter of this one is reduced, and then they put the pressure 1 and pressure 2. Once you can measure the pressure 1 and 2, you can actually calculate the Q, volume flow rate. Okay, the flow rate. And the second option here, they put a small restriction here, like a small restriction here, in which this will disturb the pressure 1 and 2, and then they put the gauge P1 and P2, as we can see here, P1 and P2, by using this restriction. This one, the restriction in terms of the diameter of this one. And the last option of this is what we call venturi. This type we call it venturi, and this one we call it nozzle, because nozzle we have just like you spray the water nozzle from the nozzle, from the bigger pipeline, and the diameter will become reduced. That is what we call nozzle. And then once we have a small opening like this, we call it as orifice plate. So these are some very popular option or approach to measure the flow rate, or in other words, to measure the pressure 1 and 2, so that we can actually calculate the flow rate. Okay, the formula, as I explained, volume flow rates equal to K constant times square root of pressure difference. Okay, drop in pressure across the restriction. K is a constant for pipeline and the liquid type. Okay, so it means that this constant is calculated based on the pipeline, the specification of the pipe, as well as the liquid type. Okay, because there are various types of the liquid, as we know. Some are very with a very high density, some are very low density like a water, some are very high density like a crude oil, for example, or maybe a slime, something like that. So this parameter can be calculated, this can be correlate, the liquid type and the pipe type can be correlated in terms of the constant, right? So okay, this is the restriction flow sensor. We calculate the flow sensor within the pipeline by using the restriction. This is a first restriction, orifice plate. You tengok ada sini pipeline 1 and 2, and then you will see we will put a orifice plate in between, and then we screw up them. This is also the venturi tube. We have this one. Okay, that is the reason, kalau you perasan, that is the reason why in the power plant, oil and gas, you can see there are too many of this one, the flanges, the pipe like end with this one, because they want to put the orifice plate, or they want to put a measurement device so that they can actually measure the flow rate. That's why you can see we rarely see a joint one straight line. Okay, within the process control, within the power plant, kalau kita tengok terlalu banyak dia punya, kalau kita mana ada gambar ini mana. Okay, kalau kita tengok kat sini sebagai contoh, lama. Okay, kalau kita tengok kat ni, for example, kita can actually, okay, sini jumpa orifice, sini jumpa orifice, sini ada orifice plate, ada pressure sensor, ada flow sensor, because they are very, very important, because this is the vessel and the flow rate are very important for a certain process, chemical process, a certain production criteria. So that's why in few meters, in just few meter pipeline, they will have flanges that they will install the orifice plate. Okay, so we will continuously see this kind of arrangement. All right, this is orifice plate, as you can see, and this is the venturi tube. Okay, venturi tube, if you can see here, this is the one that we use to measure the pressure 1. This is pressure 2. This is the one that we use in the pipeline. Okay, then this one will be connected to the DVLT, so that we can actually measure the pressure difference. All right, okay, this is very typical illustration if you go to the oil and gas industry, in which you will constantly see this arrangement. Okay, as you can see, we have pipeline which been separated by using the orifice plate, and in between the orifice plate we have the one that will be the device or the equipment that been equipped to compensate to because there will be a pressure loss once you have a pressure difference. Once you have a orifice plate, there will be a pressure difference, and then once a different, the machine, okay, the pressure sensor and the pump is required, sometimes is required to boost the pressure back to the normal. This is the flow computer and local. Okay, as simple as this one. Okay, the arrangement of the flow rate in the pipeline. So kita nampak, we just think that this can be easily measured, but in practice the arrangement will be kind of this one, quite complicated. It's not straightforward. We put the orifice plate, and then we put the gauge, we put the pipe here, complementary auxiliary pipe to measure, and we need also to include certain equipment so that we can proceed with the measurement, required measurement. Okay, all right, sensor. Are there limitation to the orifice? Okay, orifice plate, we use the orifice plate. Typical accuracy dia adalah 2.2 to 5 of span, maksudnya 2 to 5%, which is relatively acceptable, not really a big one. And okay, the general meter equation, general meter equation is this one. F is actually the volumetric flow rate, okay, and then V is the velocity, and then F is actually friction loss, and then density cross section area. There are some parameter in which we use to calculate the constant to be involved by using the orifice. Okay, and this is C meter, from this one, general meter equations. So we assume that the meter coefficient is constant. Okay, this is constant for the meter. Okay, kita ada gauge tadi kan. Okay, this one. Kita ada gauge ni and kita ada meter for monitoring, and then we assume the constant for meter at this point. We assume that the meter coefficient is constant, and this assumption is acceptable for very high value of flow. Okay, kalau flow rendah mungkin tak valid. And that means if we are using the assumption here, the assumption made only valid for higher values of flow. Okay, higher value of flow, typically 25 to 100% of the maximum for the orifice plate. These are the limitations of the sensor. Means that accuracy dia still ada, bukan 100%, 2 to 5%, and the assumption is valid, is only valid if the flow rate is relatively high. Means that below than 25% mungkin tak tepat, bacaan kita tak tepat, ataupun kita tak boleh pakai, we cannot simply use the orifice plate to obtain or measure the flow rate. Okay, what is the downside, the key disadvantage of orifice meter? As I explained before, okay, because we have two region 1 and 2, separated by this orifice plate. Okay, once we have this one, normally there will be a pressure loss. Once you have the pressure difference between two, the pressure at region 2, at this region, will never get back to the original pressure from the pipe 1, from the section 1. Okay. So what will happen when it pass through the orifice plate, the pressure will be dropped to a certain values. Okay, to a certain value. It will never come back to the original one. It will regain, but not a slightly lower values, and this is what we call non-recoverable pressure drop. So kita tak boleh buat apa. Okay, when cause of the pressure increase by 1, okay, what we can actually do, actually, ini dah saya kata tadi, we need to install some sort of motor pump or some sort of auxiliary motor pump to increase the pressure back to the original level. Okay, we need to use an external device or external pump in order to address the non-recoverable pressure loss. That is the downside. Means that we need to know the flow of the fluid within the pipeline. What is the method? We use the orifice plate. By using the orifice plate, the pressure difference, the pressure in the section 2 is reduced, and then we need to equip the pipeline with the external machine or pump in order to try to regain to its original pressure difference, the required pressure. Otherwise, it will never achieve the one that we want. Okay, on the other side, on the other part, the liquid at this region is a bubble point. Okay, and when we have the small gap here, when there are a pressure between 1 and 2 point, there will be an issue of what we call as a cavitations. I do believe if you listen to the chapter 3 notes, I mean the recorded lecture, you will came across this cavitation phenomena, which is due to the pressure difference between two regions. Like this one, this will cause a cavitation phenomena. Or maybe I will, if you listen, if you go through the valve, you should understand well in about the cavitation. But that is purely based on the pressure difference. Okay, these are, wait, Okay, these are two major downside of the orifice plate. One is the pressure loss, and the other one is cavitation. Okay, there are two phenomena with related to the orifice plate. And if you want to add some more, this one only valid. The third one will be this one only valid for higher value of flow. Kalau dia rendah, kita dah tak boleh pakai. If the flow rate is very low, so orifice plate may not be a good option for you, for us to use, for engineer to incorporate in their system. Alright, again, okay, work example. Okay, flow rate can be controlled from 20 to 150 gallon per minute. Macam tadi, previously per second, now per minute. The flow is measured using the orifice plate system such as figure 1, figure 39. Okay, assume the previous illustration. Okay, the orifice plate described with, okay, K 119.5 gallon per minute per PSI. Okay, sama. Then the pressure is measured LVDT. The sensitivity is 1.8 volt per PSI. Okay, find the range. The same one. Okay, you can go through this one by yourself because I explained to you earlier, and the approach to calculate this one is exactly the same, not much difference. First, you use the formula to calculate the pressure difference, and then once you got the pressure difference, you convert it into the PSI. We've got the values, the unit is in PSI, and then next we can actually convert based on the output sensitivity. All right, factor in selecting an orifice plate. Okay, these are some common factor. Some common factor that engineer normally consider for any sensors. Okay, for any sensors, not only orifice, but in many sensors we are trying to consider about the accuracy, whether it repeatability, reproducibility, lifespan, reliability. These are the things that we considered. Okay, so when talking about the orifice meter as a sensor or any device as a sensor, we try to take into consideration all of this. And the cost, for example, even though it is safety and cost, even though they are at the bottom, but they are equally important. And in fact, these are maybe the primary consideration for any engineers to choose, to consider first before they can consider about others. Means that we want to use a device that is really safe. If we can actually maybe compromise about the accuracy as long as it is safe, and we want to go for something that is economical. Means that one device costs you about 100k, 100 ringgit, for example, compared versus to the one that 100,000 ringgit, but the accuracy is just, okay, the one with the 100,000 ringgit, the accuracy is 2%, but the one with the 100 ringgit, the accuracy is 5%. So as engineer, we need to consider which one you want to give the priority. Depend on the application. If the application really need to go for accuracy, like it or not, you have to spend more. And if the accuracy you can tolerate with the accuracy, then you can go for the cheap one. Okay, so safety, cost, and accuracy, these are among factor that need to be considered by engineer, especially those who are working in the consultant firm. Okay, you got the job to measure certain things. What you have to do, your boss immediately tell you, okay, go for the blah 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 with a certain budget and limitation. That is the role of engineer, which cannot be replaced by a machine. So we need to decide which one we want to go for. Okay. Previously, flow sensor is measured by restriction. Okay, restriction, including the orifice plate. And now the flow sensor is measured by using obstruction. Okay, obstruction. Okay, the method 2, approach 2. Previously it was restriction and now obstruction. What it means by obstruction is this one. For example, okay, we have a tapered column here. Okay, column this one, slightly bigger than the lower one, and then we have a float. Whenever we don't require, this float will actually come to this point, and then it will limit or reduce the in term of the flow. The best example of this is actually in carburetor lah. Those I think those who interested with the motor kereta ni, the car, carburetor is one of very carburetor minyak tu is one very popular, the one that they are using this kind of technique. Obstruction means that whenever we have we don't need the we don't need the flow. This one will come to this point and it will block the input or out in from this one, and then it will block into the out. Okay, and then some of them like this one, a rotating vane. We have a rotating vane, and then this one connected to the external device, and then that can actually measure. And some of them we use the turbine. The rotation of the turbine is attached to the tachometer, and tachometer will give the value which can be translated into the flow. These are among the example by using the obstruction. Okay, obstruction. Okay, some figure for you to improve your, to enhance the understanding. Okay, these are the common pipeline. If you consider this one, the common pipeline, if you can see in the oil and gas power plant. Okay, we have here this the flanges at this point, the flange at this one, and then what we connect here, we have fluid, we have obstruction. This is the obstruction. The obstruction, say if it is a turbine, this one will rotate and this one will connected to the gauge, and we can actually read what is the flow of this one attached to the tachometer, attached to some other device, external device, so that we can accurately measure that one. And then some of them is equipped to this one, like they are measured by fluid stream. Okay, this is a turbine, example of turbine, a body, a turbine, a rotor, and then magnetic pickup. These are the way they measure the flow sensor by using the obstruction. Okay, flow sensor, what's next? We will use rotameter. Rotameter. Okay, tadi restriction, by obstruction. And then now we use the rotameter flow sensor. So that what happened is that we use this one to actually measure the flow. The flow of there are a gauge outside of the rotameter, and from this one this will give the difference in terms of the measurement. They have assembled device inside here. So based on this one, this will give change to the meter outside here. Okay, that is rotameter. And we also have a magnetic flow meter. Okay, some of these devices are very complicated in terms of assembly, and some are very simple, some are very costly, some are very cheap. Some are easy maintenance, some are not. Okay, so it's depend to application, the one that we're going to use. Some of the thing cannot be, maybe orifice meter not applicable. For example, the one with the slow flow rate, so they need to use other sensor that is suitable enough. But this is some of the technique that can be used. For example, like we have a coil, we use the magnetic fields to actually measure the flow meter, excitation current, so that this current will reflect to in term of the voltage. The voltage, from the voltage, kita tahu measurement voltage, and then that will be translated into the velocity, for example, the flow rate of the fluid. So these are some parameter, have a look, and we don't need to go in details. And then what most important, you need to know the flow meter or flow of a fluid within the pipeline can actually be achieved by using several techniques, and it's depend to the application or to the priority of the each particular process. Okay, we have covered about 4 approach. Restriction, orifice meter, obstruction, and then we have a rotameter here, flow sensor, and magnetic flow sensor. So now we come to the second parameter. Tadi flow meter, the flow of a liquid fluid. Now we come to the temperature. Okay, how we measure the temperature? What is the importance? Of course, if we don't need to know the temperature of any fluids or any device, we don't install the temperature sensor. We don't need them if the application doesn't require measurement in terms of the temperature. Okay, but we need to install if we require for the certain process control, need to measure in terms of the temperature of the fluid, or maybe something related to the food. For example, you need to boil the milk. To pasteurize the milk, you need to boil the water for we need to boil the milk for at 100 degrees Celsius for 1 hour, for example, kan? That kind of things. So in this case, we need to use the temperature. Okay, there are several approach as well, just like a flow sensor, and some of them like this one. Local display is possible using the thermometer and bimetallic sensor. Yeah. So as I explained before, why we need a local display? And this one, we need to install the display at this point, sedangkan we already have the control room to actually know the difference or the temperature, etc. But when come to the maintaining, sometimes we really need the sensor or the measurement on site, which mean on site, so that the maintenance can be done easily, effectively. So what some of the important element of this one, sometimes maybe there are device that don't even need the external power, and they are very cheap. Okay, one of them is simply the thermometer, and the other one is the bimetallic sensor. Okay, let's look at this point. Okay, the bimetallic metal. Okay, bimetallic is based on the thermocouple concept. Okay, thermocouple concept. Okay, what it means? Okay, we have a bimetal. Okay, some metal are very sensitive with temperature, some are not. Okay, this is what we call as specific metal pair that been used attached together, and then these properties, the properties of the metal, for example, if we compare alloy versus aluminium, if you heat up aluminium, you can easily feel the heat, because the properties of aluminium is the conductivity of the heat is very high, so that once you lit up the light at one end, you can easily feel the heat on the other end in the quick one. If you heat up, for example, a wood, definitely you don't feel the heat. If you heat up the alloy or metal, it will take time to reach at your fingers. These are depend on the properties of the material. This is what we call Seebeck effect. Okay, when two wire compose dissimilar metal, ada dua metal, for example, alloy attached together to the copper. They join at both ends at different temperature. Continuous current which flow in the thermal circuit. There will be a continuous current which flow in the thermal circuit. This is what a Seebeck effect. Means that Seebeck discover this, and this concept is being used for the thermometer. I mean for the thermocouple. Okay, we have one end, the candle here, heat up this point, heat junction, hot junction, and then we have two wire. Okay, two wire, and then the cold junction as a reference, we have copper, and this one we have metal to iron. So we have a voltage, so you can measure the voltage difference, and then from there we should be able to measure the temperature. Okay, example. Okay, determine the terminal voltage of thermocouple with alpha, and this is a coefficient 40 microvolt per degree Celsius. Okay, 40 microvolt per degree Celsius if the junction temperature are 40 and 80. So these are the formula. VAB voltage is equal to coefficient times pressure, temperature difference. So we know the alpha, the coefficient here is 40 micro times 80 minus 40 will be 40. So it gives us 1.6 millivolt. This is what is based on. This is the one that we measured. Okay, so means that like this one. Okay, if we measure the pressure temperature difference between 40 and 80, so we know the voltage will display 1.6. If 40 if the reference point, and then the voltage will give us 180 if 1.6 millivolt if the temperature reach 80 degrees Celsius. Right, so please have a look at this one. A very simple, but I would remind you there is a lot of tip and tricks with related to these simple questions. Student might lost with the formula, with the units. The values given here is degree Celsius, and this one is degree Celsius. So everything need to be in degree Celsius. If the constant is given in Kelvin, so you need to convert your values in terms of Kelvin. So be careful of this one. Otherwise, you will simply lose a very easy marks just by this simple mistake. Alright, this is the bimetal device. Okay, bimetal device as I explained. Okay, we have one, for example, we have two device, copper and iron, for example, low expansion coefficient, high expansion coefficients, one fixed, and then you heat up at one point, and then due to the expansion coefficients, because of the thermal coefficients, and then the copper will start to expand first, and then that will push this one toward down. Okay, the concept is being used, and then this turning down of this metal will affect this one, the gauge, for example. That's why it's showing 70 degrees Celsius, for example. Okay, so sometimes we will have this bimetal in terms of the spring, the spiral shape. The spiral is fixed into this gauge, and then we can actually see the point here, the difference, etc. and sometimes they are connected into the liquid or gas field system. Means that they don't use the bimetal device, but now they actually use liquid or gas. Liquid, very simple example for liquid is paling mudah lah. Paling mudah is apa? Yang kita dapat dalam termometer, mercury. We have a mercury. Once dia panas, dia akan kembang. It will expand and it will rise up to a certain values. And then once it cool down, it will shrink and then it will go to the certain values. As simple as that. Okay. Alright. Thermocouples again. This is kita faham dia punya konsep. And then one minute. Okay, for some cases, okay, if we plot a voltage versus temperature here, and we have a millivolt and this one is temperature. Okay, we have a certain device and a metal. Okay, if we plot between millivolts and temperature, we will see a various relationship which difference depends on the metal types. Okay, so actually this is just for us to see what type of equipment, what type of metal that suit well in terms of applications. Okay, so and to a certain extent we can actually correct the non-linearity. For example, if we see K, okay, what is K? Is chromel versus aluminum. So if we can see here, the path line is kind of linear. Linear. And this one, E. Okay, E constant is linear for a temperature less than 50 degree, but it's become non-linear above 50 degree. The same goes to any other. So based on this relationship, we can actually pick and select or maybe correct. Try to fix the non-linearity so that we obtain what is the desired value. Okay, what is RTD? Okay, RTD is again a temperature-based sensor which is resistant thermal detector. Resistant thermal detector. Okay. This is used based on the electrical conduction of the electrical or the electrical resistance. Of course, the electrical resistance will be depends on the temperature. The higher the temperature, the higher the electrical resistance. Okay, so by using this concept, we can actually using the RTD, this one, the RTD device as a temperature sensor, so that we can actually measure the temperature of a certain device. And this is very high accuracy, 0.1 degrees Celsius. And on the other hand, it is more expensive than the simple thermometer or maybe a thermocouples. By metal product, maybe this one is more expensive by using the RTD. Again, the sensitivity is 0.1, but maybe for thermocouple, the sensitivity is maybe just 1 degree Celsius. Okay, so you pick whatever you need, then that will that is how instrumentation engineers to decide for this type of sensors to be used in each applications. Okay, so this is RTD. Okay, RTD structure. Roughly, you can Google for a detailed explanation or maybe YouTube. So we have a sensing device here, and then this is connected to the circuit, and then it will react and behave based on the sensing device here. Okay, what is thermistor? Okay, next RTD. Tadi RTD resistant thermal detector. And now we call it thermistor. Thermistor electrical resistance depends on temperature. Okay, with lower temperature having higher resistance. This is what we call as thermistor. Okay, thermistor ni, okay, if by looking at these properties, we can understand that thermistor can be only accurately used for what? For a higher temperature measurement. Okay, because we have with lower temperature having the high resistance. If you can see here, the resistance of this thermistor is very high and it reduces exponentially to 0 once the temperature is increased, in which the RTD is almost linear. Once we increase the temperature, the resistance will increase, and then this one linear. So this one. So we will use a thermistor. The characteristic of the thermistor is slightly different, in which we come to almost infinity resistant, but when we come to a certain threshold level, it will come to zero resistant or nearly zero. It will become conductive. Asalnya thermistor ni is become insulative, but when a very high temperature, it will become conductive immediately. Because once you reach this point, the resistance will become a conductor. This is also high accuracy, much less physical robust, loss accuracy operated outside the recommended range. Maksudnya means that kalau you operate at range yang tak sesuai, dia tak accurate lah. So it need to be used in the appropriate parameter. Okay, that is a thermistor. That is also electrical resistant device based on the temperature. Sama macam RTD. It's just the different in term of the relationships here. This one is almost linear and this one is exponential. With the low temperature, it will having the high resistance. Okay, next we come to, we done with the flow rate, we done with the temperature. Okay, now next, what we're going to measure is actually the pressure. Okay, pressure pressure affect chemical reaction, separation, and many other key performance indicator. It should not exceed the strength of the vessel. Okay, what it means? Okay, what most important in this one? Okay, we have a certain process, and when we come to a pressure, obviously there will be a limit for each particular vessel or tank. So we don't go to exceed the strength of the vessel, so that we keep everything is keep in the safe threshold values. All right, burdened tube. Verdant tube, we can actually use the verdant tube by concept this one for a local display of the pressure. You can simply install that one on on the certain vessel, and then the pressure from the vessel will push the gauge. So this one, the needle will change depends on the pressure within the vessel. So this one this one is just a mechanical part. It's just a mechanicals, and then it will change depend on the pressure inside. Okay, if you can see here the pressure at this point, it push this one and it will push this spring to push the needles. The needle will show whatever values for this one. This is very straightforward, and what's a good thing about it, we don't need external power, and that this one is relatively cheap and easy for replacement. Okay, some pressure by using a strange gauge. A change in strain effect the electrical resistance of the metal. Okay, let's see this one. We have a bellows. Ini kita panggil bellows. Ini kita panggil bellows. Okay, we have a pressure. Pressure goes into bellows. And then we have the pressure based on ATM values. And then this bellows will push away this one. And then this will give a values. Values in term of electrical resistance. Okay. This one pun sama. If you look carefully, pressure reference at this point, vacuum or atmospheric conditions. And then we have a pressure here. Let's say this one is a tank, a gas tank. This one connected to the gauge, and this tank will push the diaphragm. Diaphragm is a film. You have a one layer. The pressure will push the layer. Layer will change the resistance of this one, and then that will reflect to the values. Okay. For example, appropriate for a range pressure from 3 to rather high up to, for example, 1400 megapascal. That is very, very high. 1400 megapascal. Okay, for a certain application. We can use this one. We use a strain gauge. Okay. Okay, for example, diaphragm. Macam saya cakap tadi, diaphragm is this one lah. We have a filament between the tube. Okay, assuming like this one, a filament something like a balloon, a thin layer of material that can be bent and can be stretched according to the pressure. This one, we install this one at this point. Okay, so this one akan bend ataupun what we call it stretch for certain values or level, and then this will give the this will help for us to detect or to measure the pressure. Pressure macam kita in the first place to measure the flow of the fluid. Okay, we have flow, pressure 1 minus pressure 2. A is the diaphragm area, surface area in term of meter cube. So we can actually force. Calculate the force is equal to pressure 1 minus pressure 2, pressure difference, times to the surface area. Okay. Okay, now we have this one, we kind of membrane. Membrane macam ni. Membrane. So sama. So we have a pressure. The pressure will push the membrane to go up. The motion of this one will give you a values or reading. Of course, this need to be calibrated. For that, we have an accurate measurement. Okay, bellows pressure measurements. Again, these are the bellows. Macam saya cakap tadi kan. As I mentioned before, we have a pressure one goes into the bellows, and this bellows, if you can imagine, the bellows is something like the plastic things that you can compress or outstretch. So it will move depend on the pressure. So the movement of these bellows will move the LVDT. This is the sensor. LVDT. This one is connected to the display device. So based on this one, also we can measure the difference. We have the pressure one. Of course, we need pressure two because under normal condition, say 1 ATM, this 1 ATM, there will no change, and then the value will show 0. If this one is lower than 1 ATM, this one will give you a certain value. So there must be a reference value. There must be P1 and P2. Okay, next, electronic conversion. Okay, electronic conversion is similar. We have a diaphragm, a thin membrane, and then the movement of this membrane will cause a displacement. Okay, if you can see here, displacement of this transducer, induction motor, we have induction motor, and then this will send out to the output. Output will give the measurement. So in this case, we have a pivot. Okay, we have a pivot. We have a beam here, and the movement of this beam will cause a displacement of this transducer, and also will cause the electric pulse from this movement of the magnet, and then that will be triggered to the output in terms of the display. Okay, the fundamental is just the same. A movement of this membrane called billows, that will depends on this each application to be used. Sometimes we want to use the electronic conversion, sometimes we want to use the LVDT. Some of the case we may need to use this kind of simple mechanical movement. It depends to the application. It directly reflects to the sensitivity due to the range, due to the cost, economy, and safety. Okay, some of the case, for example, maybe if the thing is being used outdoor and we need to submerge in water, maybe electronic conversion is not suitable because they are electronic. We need to go for application that is submerged in water. Maybe we need to use some sort of simple mechanical approach rather than electronic part. All right, and then we have a solid state pressure sensor. Again, the same concept, there will be P1 and P2. Okay, and the difference in terms of any of those will cause a pressure difference. Pressure difference. So I don't want to. Okay, and we also can detect the pressure by using a capacitant. Capacitant electronic juga. This one is also electronic. A change in the pressure deflect the separating diaphragms, which affect the capacitance. Okay, we have a pressure 1, pressure 2. Of course, one will be a reference pressure and the other one is the measured pressure. So once we have the pressure, this pressure will change the capacitance value, and this capacitance value will be converted into the electronic circuit here, so that we can actually see what is the output. And to a certain level, we may need to amplify the signal so that that is readable. Okay. To pressure. Okay, pressure using potentiometer metric. Potential metric. Okay. So what we need to do, we convert the deflection of the arm to change in resistance. Okay, what is the pressure? We have the pressure here. We have the billows. This one will go up and down. That will change the spring. We have the connecting rod, and this connecting rod will move. Okay, this is the resistance. The movement of this connecting rod, if you can see here, will change the potentiometer. So when the potentiometer is different, this will change in terms of the resistance values that will be directly reflected to the circuit. I mean the voltage level. Okay, once we change the value of the resistance, the voltage or the Wheatstone bridge circuit, if we use the Wheatstone bridge circuit, that can easily be found. Okay, they are not accurate, but this one is appropriate from 5 to 10,000 10,000 psi. It depends. Very simple and less expensive, but they are not accurate, as I mentioned, because we are talking about a very wide range up to 100,000 psi. Okay, now we come to the last. Okay, we come to the last measurement device, which is a level. Okay, we covered the flow measurement, flow sensor. We covered the temperature sensor, and the third one we covered the pressure sensor. These are the three, and the last one is the level, which is the most. These four sensors are the most popular one that been used in practice, or the one that we consider as the frequently used in practice, especially in the instrumentation. Okay, measurement level is very simple. We have a tank. We want the tank, the water to fill in the tank to a certain level. The simple example is just maybe toilet tank, flush. The water will fill up the tank once we flush, and then it will, by using a float, it will rise up until this mechanical part will actually close the what you call it, the output ataupun input from the pipeline. Okay, this is by using the float, and we can actually have a simple uh, cylindrical capacitor. We install a cylindrical capacitor, and we install the capacitor here, and then we can proceed with the measurement. This is also another approach, and the water level or the fluid level within this tank will determine the water level within this vessel. Okay, based on the capacitance values. Huh? This one is the most simple one, just a float and mechanical approach. Okay, electrical level measurements. Kalau kita tengok sini, okay, a conductive electrical level measurements kan. Tadi ada, there is one mechanical part, and then we go to electrical. Okay, we have a minimum level here, maximum level, and we have a probes. We have a probe here installed, this one, and we have a vessel within this one, and then this one earth. Okay, so this one, everything is connected to the this one, what you call as a capacitor, electrical level. We measure in term of the electrical. Like this one, we submerge the sensor, the sensor within the fluid, and then we measure the in term of the voltage level based on the capacitance values here, right? The capacitance values within the fluid, that will determine the height of the water or the fluid within the vessel. Okay, sometimes we can actually measure the level of the water in the tank by using ultrasonic. Okay, this is very popular for fishermen. They want to detect, they use ultrasonic to detect a fish. They use the ultrasonic to detect the water sea level. And this one is they bombard the signal to the bottom, and then they measure how fast the receiver to accept the ultrasonic sound. And that is how they measure the distance. Okay, level. Local display is useful. As we explained many times before, for maintaining purposes, sometimes we do need the local display. As simple as a tube, small tube like this one, so that we have a container. We have a container here, and we don't know what we cannot see. I say the container is a steel, and then you don't see the water level. Once you have introduced a tube, a glass tube outside the container of this one, then you can easily see what is the water level as this one. This is particularly important for the maintenance purpose. Okay. Okay, some of the water level sensor, we use a displacer. Okay, displacer is a sensor measure that weight of an object suspended in the liquid. Okay, we have a tube here. Okay, we have a tube. Okay, what you do, we have a certain object inside here, and then we have a certain weight. And this weight will be varies depend on the water level. When is the weight of the water level will directly connected to the electric circuit. This is the principle of Archimedes. Kalau you still ingat, you remember our science subject in primary school, primary ke secondary school, can't remember, but this is the concept. Once you go into the bathtub, the water will flow out, and then our weight will be varies. Our weight will be varies because we are floating in the liquid. That is the concept that they use to measure by using displacer. Okay, and then we may use a differential pressure. Okay, ini cara susah lah, to be honest. The simplest one, just install a tube outside this one, you can easily see the water level. That is very simple, straightforward. And of course, as I mentioned, some of the device or sensor may not appropriate, may not suitable for a certain application. So like it or not, we have to go for some alternative. Maybe we need to go for differential pressure because of certain condition. In this case, we have the pressure, we have the tap here and here. So the difference in terms of the pressure between these two one will be converted into the water level or pressure or liquid level within the tank. Okay, yeah, of course you can read the instruction, the explanation given here. So I think we come to the last page of okay, yes, last page 55 or 55. All right, so for today, I think I've covered the second part of this chapter about the sensor. We discussed about okay, as I mentioned in the second page of this one, we're going to learn or to see sensors on 4 parameter. We've got temperature, pressure, flow sensor, and level. Okay, each of this one, they have a certain condition, certain criteria, certain measurement approach. Each of this one. So we covered all of them. So you may review all of this based on this one, based on this simple explanation. At least for you to understand what is important, the concept that we discussed earlier. Right? So, any questions up to this point? Mana ni? Okay. Okay, any questions so far up to this point? Naim Rizwan,
Yes, Doktor.
ada soalan? Any questions?
No, Doktor.
Abdul Wali, where is Abdul Wali? He didn't join the class.
Yes, Doctor, yes.
Yes, you managed to join. You are the Hajj Kali just now, right?
Yeah, I've joined. I have changed the email.
Okay, good. So, can you follow the class, my explanation before?
Yeah, I have followed the class here.
Okay, good. Adila, ada soalan?
Tak ada, Doktor.
Okay. Okay, kalau tak ada soalan, saya rasa saya stop at this point. And saya akan start bagi, okay, just to, saya akan stop at this point. Let me just stop the recording session now. How to record? Stop recording.